In the very beginning of this course, I said that call expressions are the only kinds of expressions we need. Well, it turns out that they're not. You also need control. Control statements include if statements and while statements that effectively describe what should happen next in the course of the program. So let's take another look at control statements, this time not just learning how they work, but asking why they're there in the first place. And you've seen this problem before. Let's try to write a function that does the same thing as an if statement. And in particular, we'll focus on this form of a conditional statement, where there's one if clause and an else clause, and no elif clauses, although that wouldn't change the story very much. The execution rule for conditional statements in general is that you consider each clause in order. Evaluate the header's expression if it's present, this has one, this doesn't, and then if it's a true value, the value of that header's expression, or you're in an else header, then you execute the suite and skip the remaining clauses. What are all these clauses and suites anyway? There's the if clause, there's the else clause. A statement, and this is just one big statement, can consist of multiple clauses in Python. There's that header expression slot, and the suite is everything indented after the if line and ends when you get to an unindented line next. So here's the if suite, here's the else suite, and the point of this execution rule is that you either execute this suite or this suite. If you do this one, then you skip the rest. If you don't do this one, then you move to else, and you always execute the else suite if you get there. So this statement, let's try to write a function that does the same thing as an if statement, is provoking you to ask the question, why do we have this in the Python programming language at all? How come we can't just have a function that takes some kind of header, some kind of suite expression, and another suite expression, and if this is true, then it does this, otherwise it does that. Now this function doesn't exist in Python, but we could imagine implementing it in a pretty straightforward way. You just pass in the predicate consequent alternative, and you use an if statement in order to do the work. Wouldn't it be nicer if everything in Python was a call expression, and so it looked like this instead of looking like that? I mean, here you have to remember how to indent, and you have to remember the colons, and everything here is just a little bit simpler. It even fits nicely all on one line. But the reason we don't have this function that doesn't exist is because of the evaluation rule for call expressions, which says that before you call this function, you evaluate this expression to figure out what function you'll call, and all of these operand expressions to figure out what arguments you'll call it on. Only then do you apply the function that is the value of the operator to the arguments that are the values of the operands. So figure out what you're going to call and what you're going to call it on, and then execute the body of the function. But that can lead to problems, because in this syntax, only one of these two is ever executed. In this syntax, they're both evaluated. Does that really matter? Well, let's look at a practical example of when it would. In Python, the square root function that's built in doesn't really like negative numbers. If you give it a negative number, then it tells you math domain error. Now, if you take enough math classes, you'll find that mathematicians have defined a result for this. They say, even though you can't take the square root of a negative number and have a real numbered answer, you can invent imaginary numbers that give you negative numbers when you square them. And after learning this fact about mathematics, you might want to define a real square root function, which just returns the real part of the square root of x. And acknowledges that the imaginary part is there, but we are not going to compute what it is. So we might write it as, if x is greater than 0, return the square root of x. Otherwise, return 0. Because the real part of the square root of -4 is just 0, and the imaginary part is 2 times I. We'll also import square root and load the file. And then we can find the real part of the square root of 4 is 2, and the real part of square root of -4 is 0. That all works fine. But it might surprise us that this works fine, because when you pass in -4, somewhere in the body of this function, it says we're going to take the square root of -4, and this function errors when it gets a negative number. The only thing that stops the error is this control statement, which chooses to only execute either this line or this line, but never both. If instead I had used my if function to try to compute this very same result, it certainly would look nice to say if x is greater than 0, take its square root, otherwise it's 0. And what about returning? Well, let's say that we can return this, and we can return from here, and that way we should be able to get the values that we want. So running this version of the code, we can compute the real valued part of the square root of 4 is 2, and the real valued part of the square root of -4 gives me a math domain error. Why? I said, if x is not greater than 0, just use 0. But because this is a call expression, all three of these are evaluated before this is ever called, and that includes square root of -4, which causes this to crash. So without an if statement, which is a control statement that gives us the choice of whether to evaluate some expression or not, depending on the value of some other expression, we can't choose between alternatives. We have to only choose between values, and that's not good enough to compute the real square root of x. So that was the whole point of the question you did on your homework. There's a reason why the Python programming language has a separate kind of statement for conditionals, instead of just using yet another function. And that's because functions always evaluate their components, but control statements skip some parts or repeat some parts, and that's just not something that call expressions can do.